All right, cool. Okay, so what we're going to do next is we're going to go into a set of exercises to understand the motion of rigid bodies. All right, so here I'm sharing the screen of my phone because we're going to be using a phone, either an iPhone or an Android will work, to sort of understand how the motion, in this case of a phone, uh, is sort of related to the angular velocity. So you're probably used to thinking about angular velocity from your physics course, probably mostly in the case of pure circular motion, sort of imagining like something spinning around, a center point, like a planet orbiting a planet's orbit or something of that nature. Here we're going to be generalizing that quite a bit. So in order to get started, what we're going to do is download an app that will let us um, basically look at the values generated by the gyroscopes on our phone. So what's pretty cool is that we have these tiny mechanical micro electromechanical systems that are etched onto the chips that are in our phones that have these little mechanisms that let us measure motion of the phone. So we can measure things like acceleration or angular velocity. All right, so we suggest downloading a tool called Sensor Kinetics. All right, so that's one we've used in the past. I noticed that on my iPhone, it doesn't actually work all that well. I think because I have a newer iPhone and it wasn't designed, the layout of the UI doesn't work in it. So as an alternate, you can go ahead and use an app called Sensor Toolbox. All right, so I'm gonna go ahead and open that up here. All right, when you first start it up, you'll see that it's going to have a bunch of different sensors that'll kind of show up. Oh, here they are. So usually these boxes are all checked. So here's a bunch of different sensors that this app is collecting. So here we have accelerometer, geomagnetic field. That would be what allows you to know what direction north is. And things of that nature. So we're going to be interested in the gyroscope. So here we go. Here's our gyroscope. All right, and hopefully you can see that on the video. So here we have some values going, and what we're going to do is try to understand, as we move the phone, how does that influence our sort of measurements of angular velocity? All right, so in exercise 30.6, we have you walk through a few different sort of experiments. And what you'll do is you'll move the phone through some particular motion, and then you'll take note of what the sort of angular velocity readings are, okay? All right, so I'll just do a couple with you all. It might be hard to see what I'm actually doing. I'm gonna try to, well, it'll probably be too difficult. Let me hold the phone up. So imagine we have the phone flat. It works a little bit better if it's actually on a table. So I'm going to take the phone and spin it around. Imagine there's a vector sort of pointing out of its screen. I'm going to spin it around that vector counterclockwise. All right. Okay, so hopefully you could see that blue curve go up, which corresponds to the z-axis. So as I did that, I got a positive reading in the z-axis direction. All right. Again, it's a little bit noisy when you are holding the phone. If you have the phone on the table, it'll be a lot cleaner. All right, so we can sort of make note of that, and then we can think about, well, what are the other two axes of the phone? So we could try spinning the phone around an axis sort of pointing out the top of the screen, all right? Okay, so you can see that yellow curve is moving, depending if I'm going sort of, counterclockwise or clockwise. So that will enable us to understand what is the sort of axis of the phone, how is the axis oriented. The convention for right-handed coordinate system is always going to be that counterclockwise rotation about an axis is going to be positive. So if we see that the angular velocity goes positive as we rotate in a certain direction, that means that that axis, a vector pointing in that direction such that that motion was counterclockwise, that would be the positive direction for that axis. All right, and then the last one would be sort of pitching the phone like up and down. You can see the sort of greenish blue curve is the one that changes in that case. All right, cool. All right, so the exercise asks you to go through some more and more complicated examples of that and try to understand what happens. We do things like move the phone linearly. It's a little bit hard to see, but you'll notice that the angular velocity doesn't really change all that much. which makes sense because it's supposed to be measuring rotation, not linear motion. All right. So hopefully these exercises will give you a sense for what's going on. We do have solutions for them if you want to check them out. All right, so let's jump back to the document. Let me stop my share real quick. All right, and then I'm going to share the document instead. Okay, and here we're thinking about angular velocity as a vector. So probably in your high school physics class, you thought of, you have omega, it's radians per second, it's a scalar. It was always clear what axis you were talking about rotation with respect to. Here, we're going to think of it as a vector in 3D space to allow us to define both a sort of angular speed, but also the direction around which we're sort of rotating. Okay. All right, so that's what's going on there. All right, so here we're thinking about what those angular velocity vectors would be for different types of motion. All right, so we'll go through the first one together and you can look at the solutions for the rest. So it says, predict the angular velocity if you place the phone down on the table and spin the phone in place so that it spins once in 5 seconds. All right, so from our previous experiments, we saw that when we put the phone flat on the table and spin it, it results in a positive angular velocity in the z direction, okay? So I say it doesn't quite specify whether we're talking about a clockwise or a counterclockwise. Let's just assume we're talking about a counterclockwise rotation, so about the positive z-axis. All right, so if we spun the phone so it rotated once in 5 seconds, we would say that our angular velocity would be the number of radians that we go through in that time divided by the time. So it would be 2 pi radians divided by 5 seconds. That would be our angular velocity. And if we actually did that with the phone, we should hopefully see that that is the case. It might be a little bit difficult to actually achieve that. It will take a good amount of sort of care, but you can go ahead and try to emulate that as closely as possible. All right, and then these other exercises ask you to do sort of various different types of motion. So we'll let you kind of go through those on your own. I won't do those in the walkthrough, but the solutions are all here if you want to check them out. Okay, all right. So that is the entire day document. So hopefully you've been able to get through those exercises. Again, post on NB if you run into trouble, and we'll give it a shot to help you out. So thank you all very much. And yeah, we're really looking forward to this module. I think it's going to be a lot of fun. And be well. All right. See you all down the road.